welcome to the third in the mini-series of cybersecurity themed C# support videos. In this challenge we need to implement a firewall. And what is a firewall? Well, it's just a list of rules, so we're going to implement it with a list data structure. So a firewall is involved when a client connects to a service or a server, and we have a list of rules to decide whether or not to block that connection or to allow that connection. So it's a really simplified firewall in this case. All we've got is a list of IP addresses that we're going to block, and if our IP address is in that list, then can connect, provided with that particular IP address, is going to return true. But if the IP address is in that list, then it's going to return false because it's going to be blocked. So let's implement those methods first of all. It's to be public for can connect. It has a return type of Boolean up here, so it's going to return true or false. And can connect should accept one parameter, which is a string. So for now, I'm just going to return true, which is obviously going to be wrong some of the time, but it should get rid of the syntax error from not returning anything. Next, we need to implement block. So at least let's put the method body in there. So it doesn't have a return type, that means it's a procedure. So we put void in here, block. Which IP address do we want to block? Let's block IP, which is a string, so that's the parameter. And then unblock. Again, no return type, no return value. Unblock string IP. Okay, so that should get rid of any syntax errors, but we'll probably still have some logic errors. What have we got? Oh, it doesn't know how to unblock because I've spelled unblock wrong. There we go, no syntax errors, but we've got some failed tests here. So this test passes because we've got no blocked IP addresses, but then if we try to block the same IP address, at the moment it can still connect because it's saying it can always connect. We don't want that to happen. We want to be able to say if we block an IP address, then that IP address should be blocked. We can only do that if we keep track of all of the blocked IP addresses. So the whole point of doing this activity is practical examples of lists. So we'll have a list of strings, call it blocked IPs, which will be a new, so we'll call the constructor to allocate all of the memory to store that list. This time we can just check and see if IP is in this list. So let's see, blocked IPs dot contains IP. So that will be true if it is in the list. We want the opposite of that, so I'm going to put an exclamation mark, and I rather hope that that will allow us to block something. Just says test failed. It can still connect. Because we're not actually adding it to the list. Let's see, blocked IPs dot add and blocked IPs dot remove. Now I don't know if we'll have an exception if we try and remove something that doesn't exist. Possibly. Let's have a look and see. Nope, that's enough. That fixes it. So what's happening here for each test? We're checking to see if an IP address can connect, even if it's not blocked yet. If we try and block it, then it can't connect. That's good. Then all of these 12 IP addresses are blocked, and we try one of them and it's blocked. We try unblocking it. Yeah, it just seems to work.